Okay, so number one, a bank account has $20,000 in it, but it's being used by a college student who takes out $300 per month. So we're going to write an equation to represent the amount of money at any time, and then go ahead and name the variables and the parameters. It says right there what you need. So the equation itself, it's always going to be in this form right here, y equals mx plus b. So really all you're doing is identifying what the m is and what the b is. So the m is your slope. The slope is what's changing each time, in this case each month. So if they're taking out $300, that would be, taking out would be subtracting. So the equation is going to be negative 300x. And then the b is what they started with. Well, the account had 20,000 at the beginning. So plus 20,000. That's all you're doing for the equation. Generally speaking, that part isn't a big deal for you guys. That should be fairly simple. And then we move on to describe the variables and parameters. Now here's where I've seen some people making some misconceptions, and you're going to miss some easy points here if you're not careful. When you list the variables, a variable is a specific thing. It's going to be days, hours, amount of money, amount of honey, amount of computers. It's going to be a specific thing. So on X, for example, read your problem. It says takes out $300 per month. So if the equation says negative 300 times X, that would be negative 300 times what? Times the number of months. So X is going to be a single thing. It's going to be almost always a measurement of time. So you look at the problem, you ask yourself, what measurement of time do I have? And I'm counting by months. So that's my X. It's going to probably be a single word. Okay? Now, Y is again also going to be a single thing. Now, a lot of people on Y, they'll put the money you started with. Y is not the money you started with. Y is the money that you have at any time. So after 1 month, I'll have this much money. After 2 months, I'll have this much money. So Y is going to represent the money in your account. And yes, at the beginning you have $20,000, but you only have $20,000 at the beginning. Then it goes down 300 and you have 19,700. So as you go down, the money in the account will follow. And so Y is just whatever that amount is. So you could put amount of money or you could put money in the account, but it's specifically, it's the money that you've got at any time in that account. All right, now the parameters, those are just describing what the problem tells you. You can probably pull it straight from the problem. So that 300, that negative 300 is what you take out each month. So we could say money out each month. So you're making sure that you can describe what's happening in that problem. And the $20,000, that's the money in the account at the beginning. So the parameters are where you kind of have phrases, where you describe specifically what it is. The variables are going to be much more direct. They're going to be specific things. X is months. Y is the money in the account. They're going to be specific things. All right, once you've got that, you're going to go ahead and graph it. Because it's a test, I want to make sure everybody's graph looks the same, so I went ahead and I scaled it for you just so that we'd all have the same graph. So we know to graph a linear equation is pretty simple. You just start at the y-intercept. So we're going to start at 20,000, okay? And then we're going to go down 300 at a time. Now, you might notice down here at the bottom, I didn't scale it by ones, I scaled it by fives. So if I'm going over 5 months at a time, these are months. This is money in the account. Okay, if I'm going to go 5 months down the road, 300 times 5 is 1,500. I'm going to lose $1,500 in 5 months. So if I lose $1,500 in 5 months, I'll be down to $18,500. Now if I lose $1,500 more in another 5 months, I'll be down to, what, 17,000. And so on. Now you don't have to graph every point all the way through, although that would be accurate. Once you've got, say, 3 or 4 points, go ahead and use some sort of straight edge so that it's clean. Go ahead and make your line. Now I put an arrow there because it is going to continue at least for a while. Okay, and remember, math is different without a story than with a story. Without a story, an equation goes forever. With a story, obviously, we're only going to have part of that line because at some point you're going to run out of money and you're not going to go negative. The bank's not going to let you have negative money in an account. Okay? All right, so we go through the features here. This part's probably the part that's going to mess people up the most. So this, if you're going to study number 1, this part's probably the part you're going to need to study. Domain and range should be simple. In a math equation, take the story out for a minute. Remember, on this part here, and you may want to write this, for a brief moment here on number 3, let's ignore the story, let's just talk math. In math, linear equations go forever. They'll go forever left and right, they'll go forever up and down. So to tell me that, you say the domain is all real numbers, it goes forever left to right. The range, also all real numbers, it goes forever up and down. So just mathematically speaking, a line goes forever. Now the limit is the same thing as in behavior. So you may want to remind yourself, those words are interchangeable, in behavior, limit. So what we're saying is, where are we headed? And limit L, that means left. I'm just abbreviating to save room here. Limit L means the left in behavior. Limit R means the right in behavior. So if we look at the left side, you can even circle it. Look at that left side. That arrow is going in 2 directions. It's going left and it's going up. Left and up. Now left is a negative direction, up is a positive direction. So that's what you're going to tell me on the limit. You're going to say, as x goes negative, because left is negative, y goes positive. And again, it's going forever. That's why we put the infinity symbols, because it's not going to stop at any time. It's going to go forever. So x goes left forever, y goes up forever. Now you can do the exact same thing on the other limit. So circle the right side. Where is that headed? So we're going to the right, but we're also going down. Now the right is a positive, down is a negative. So on this one, it's kind of the opposite. As x goes positive, the y goes down, which is negative. So we go right and down. Right is positive, down is negative. So a limit is really you just giving me directions. Tell me the 2 directions the arrow is headed, and you're good. Okay? Intercepts. The y-intercept is almost always going to be the easiest, so we'll start there. The y-intercept is your starting point. We said that was 20,000. Now don't write 20,000. Write it as a coordinate, so it would be 0, 20,000. Now the x-intercept, that one's the one that throws people off because you don't get a free answer. You don't get to just write something down that you can see. The x-intercept is if I continued that line, where would I cross down here? You say, well, I don't know, I can't tell. Well, if you can't tell, then we go ahead and say, well, what do I know about that point? Well, I know that that point, the y would be 0. The question is, what is the x? So if I know that the y is 0, I can go ahead and I can do the math for that. I'll tell you what, I'll just do it on this right here. I can do the math for that and figure it out. So if I know that the y is 0, I can plug that in. And as long as you can solve an equation like that, you can get the x-intercept. So the x-intercept is not as easy as the y. The y you can just point at it and write it down, no big deal. The x-intercept, usually you're probably not going to be able to see it on the graph. So if you can't see it, you have to actually figure it out. So I know the y is 0, so I subtract 20,000. And then I divide by negative 300. And that's going to be, well, let's cross out a couple zeros. That's going to cross out the negatives. That's going to be 200 thirds. And you don't have to know what 200 thirds is. You can just write it as a fraction. Okay. 200 divided by 3 is going to be about 67 or 8, right? I think 67-ish. Okay, and then finally, INT down here, these stand for interval, just like we did in class. So interval increasing, interval decreasing, interval positive, interval negative. The increasing and decreasing part should be easy. When you look at that line, it's obviously going down. It's not going up. We read it left to right, and this thing goes down forever. Just keeps going down. So it's increasing never. You can actually write that. You can put never, you can put NA, you can put doesn't do it. I don't care. It's never increasing. Now it's decreasing all the time. So to give me an interval, you're telling me it starts decreasing here and it stops decreasing here. Now if it's doing it forever, it's going to start at the beginning of time and it's going to decrease forever to the end of time. So on these intervals, you're telling me from here to here. So from the beginning to the end, we're always going down. Now positive and negative is the same way, only in this particular problem, it does change. Right here, circle that point, go ahead and extend that line, circle that point. Right here is where we switch from being positive values to going down into the negative values. And we already know where that point is. That point is that x-intercept that we found just a minute ago, 200/3. So we are positive on a big part of this. We're positive from the beginning of this graph. When this graph starts, it starts at positive infinity. We're going to continue to be positive until we get to this point right here. And we already know where that point is. That point's at 200/3. Now, the second we cross that line, we crossed over into the negative numbers. So when are we negative? We're negative from that point until forever. We will continue to be negative. This graph is not going to suddenly turn and go back up again. So we're going to continue to be negative for the rest of the graph. So that would be from that point to forever. And you know what? You can circle that x-intercept and you can draw arrows here. The positive and negative will always change directions at the x-intercept. The x-intercept is the point where you switch from being positive to being negative. So that number that we had to find on this little post-it here is the same number you're going to use in all three of those places, because you're telling me where we switch from positive to negative. All right, so part 4 here. This is all one big comprehensive problem. Part 4, how long will it take to empty the account completely? I think that was I started to write something different and never deleted it. I should just say to empty the account completely. Now, you ask yourself, how much money would I have if I empty the account completely? Well, hopefully you would have $0. Now, we already did that work. It's right here. So how long would it take to fill the account completely? 200/3 months. Now that's a weird way to write months. If you wanted to go ahead and say that 200 divided by 3 is what? Wait, 66 point. If you wanted to go ahead and say it's somewhere between 66 and 67 months, that'd be okay. But honestly, if you leave it like this, that's fine too. That's an exact answer. There's nothing wrong with leaving that answer. Now it says show your work algebraically. I'm not going to put it in here just because I've already done that, but this is the work. This is the work that I would have put in that box. So the same work that you did right here, I don't know if you did it over here on the side or if you did it on a separate sheet of paper, that's the work that would go right here because it's the same question. Emptying the account completely is $0. That's what we found right there. Now it says how much money will he have left after 2 years? Okay, now what you're not going to do is plug in a 2 because we're dealing in months. So if we're dealing in months, 2 years is 24 months. So we're going to take our equation and we're going to put a 24 in there for the months. Okay? Now, save ourselves a little bit of time here. Negative 300 times 24 plus 20,000, we're looking at $12,800. So in 24 months, taking away $300 each month, we're going to have $12,800 remaining in that account. And showing me the work, there's not a lot to show. Just show me that you understand that you have to plug it into X, because X is months. Okay? Now, across what interval is the model useful? You look at this and you say, wait, I already did domain and range. Okay, now I want you to stop thinking about domain and range mathematically. Mathematically, it goes forever. I want you to start thinking about the domain and range in the story. If we start with $20,000 in our account, there is no before that. And when we deplete our account to zero, there is no after that. As soon as the account reaches zero, this graph is pointless. So I want to say basically what part of this graph actually has meaning to my story. And so in my story, I start at a domain of 0 for x, and I continue until I run out of money. And we already know that point. You don't have to calculate that point over and over again. It's still 200 thirds. So the domain is useful until we run out of money, which is 200 thirds months, or 66 to 67 months. Okay? Now the range, when is the range useful? Well, the range is useful from $0 to $20,000. That's the most and the least amount of money that you have. That account is never going to have more than $20,000 because that's what we started with. And it's never going to have less than 0 because you can't go negative in the bank. So the usefulness is responding to the story and making sure that you know how much would actually be worth looking at as far as the story is concerned. And then finally, explain what the x-intercept means in the context of the problem. We've already kind of described that before, so we'll just be explicit here. That's the point where you run out of money. Or I can say where your account hits $0. You can say that's where you run out of money, whatever. The x-intercept is when you are done. There is nothing left.